AWS Solution Architect Associate Chapter 7, VPCs. Virtual Private Cloud lets you provision a logically isolated section of the AWS cloud where you can launch resources in a virtual network you define. You have complete control over the environment, including selection of IP address range. One subnet equals one availability zone. You cannot have a subnet across availability zones, but you can have multiple subnets within an availability zone. Creation of subnets, configuration of routing tables and gateways or IGWs. Network config is easy to customize. You can create a hardware VPN between your corporate data center and AWS, to use the AWS cloud as an extension of your DC. Use network Acls as a first line of defense, as they allow specific blocking and are stateless. Security groups are next, and stateful. A Bastion server is an EC2 instance in a public subnet, used to connect to an instance in a private subnet. What do VPCs let you do? Launch instances into a subnet of our choosing, selecting custom IP addresses. Configure routing tables between subnets, create internet gateways and attach to VPC. Better security control over AWS resources, instance security groups, subnet network Acls. Default VPC is very easy and allows immediate deployment of instances. All subnets in a default VPC are internet accessible. Each EC2 instance has a public and private IP. By default, you can have 5 VPCs in each AWS region. VPC peering allows connection of 2 VPCs using private IPs. You can peer with other accounts, as well as within your own. There is no transitive peering. One VPC is connected to others, so A connects to B and C, but if A connects to B which connects to C, A will not have access to C. Peering has to be direct point-to-point. Also possible to peer between regions. When a new VPC is created, no subnets are created automatically, no internet gateway, but there is a routing table, a default network ACL and security group. A subnet cannot span more than one availability zone. Auto-assign public IP address by default is off on subnet creation. 5 addresses are reserved in a subnet by was, 0 for the network, 1 for the router, 2 for the DNS server, 3 for future use and 253 for broadcast. Only one internet gateway per VPC. All new subnets not assigned to a specific route are added to the main route by default. It is therefore best practice to make the main route private and non-internet connected so as to avoid making everything publicly accessible by default. Security groups do not span VPCs. ASes are randomized across accounts, so US East 1A might be different on your account to somebody else's. Nat Instances versus Nat Gateways. A Nat instance is an EC2 system, which therefore needs to be patched and managed. A NAT gateway is a highly available gateway to allow systems communicate with the Internet without becoming public. NAT instance, remember to disable source/destination checks on your EC2 instance. A NAT instance must be able to send and receive traffic when the source or destination is not itself. A NAT instance must be in a public subnet. There must be a route out of the public subnet. NAT instances are a bottleneck, can increase instance size, and single point of failure. High availability zones can be created using auto-scaling groups, multiple subnets in different ASes and a script to automate failover. NAT instances are always behind a security group. NAT gateways are redundant inside an availability zone, but you can only have one gateway in an AS less than and cannot span ASes. They have a throughput of 5 gigabits per second, scaling automatically to 45 gigabits per second. No need to patch OS, and NAT gateways are not associated with security groups. NAT gateways are auto-assigned a public IP, just update the routing table for 0.0.0.00 to use the NAT gateway for internet connectivity. If you only have a NAT gateway in one AS, and that AS fails, you risk losing internet connectivity. Consider a NAT gateway per AS, and configure routing to use the local AS. Network access control lists versus security groups. Network ACLs are associated with VPCs, and can only be associated with a single VPC. On creation of a new network ACL, everything in and out is denied. A VPC comes with a default NACL which allows everything in and out. Custom NACLs can be created, which by default block everything in and out. A subnet can only be associated with an NACL. Associating a subnet with a NACL breaks association with previous NACL. Rule numbers are recommended to increment by 100 each time. With NACLs being stateless, outbound rules need to be manually created to match inbound. Ephemeral ports, 1024 to 65535. Short-lived ports for transactions between servers. Receiving service normally static. This is done to permit return traffic, and are only valid for the duration of communication. A NAT gateway uses ephemeral ports 1024 to 65535. Network ACLs are processed in order, so deny rules must be listed before allow. Subnets on creation will be associated with the default VPC NACL if no other assignment is provided, but can be associated with another you create. They can only be associated with one NACL at any one time. NACLs are evaluated before security groups. Block source IPs with NACLs, not security groups. NACLs can deny or allow, and are stateless. Custom VPCs and elastic load balancers. A load balancer needs at least 2 public subnets with internet gateways. VPC flow logs capture information going to and from network interfaces in your VPC. Flow log data is stored using CloudWatch logs, so after creation the logs can be consumed via CloudWatch, can also be stored in S3. Flow logs at 3 levels, VPC, subnet or network interface. You cannot enable flow logs for VPCs that are paired with your VPC, unless both are in the same AWS account. Flow logs can be tagged. After a flow log is created, its configuration cannot be changed. Cannot change IAM role. DNS traffic is not logged, unless an external DNS server is used. Traffic generated by Windows for Amazon Windows license activation is also not monitored. Traffic from 189.254.169.254 for metadata is not monitored, nor is DHCP or traffic to the reserved IP of the default VPC router. Bastion hosts are servers that are designed to withstand attack. Usually available on the internet and used for remote access to systems on the private network. A NAT gateway is used to provide internet traffic to EC2 instances in private subnets. You cannot use a NAT gateway as a Bastion host. Direct Connect makes it easy to establish a connection from your premises to AWS, reducing cost, increasing bandwidth and providing a more consistent experience. Useful for high throughput and security. Customer connects to a router owned by them in a direct connection, DX location, AWS partner router also possible, that connects from one cage to an AWS dedicated cage router over cross-connect, which connects to AWS over the backbone. Never traverses the internet. Steps to set up a VPN over Direct Connect. Create a virtual interface in the Direct Connect console. This is public virtual. Go to the VPC console VPN connections and create a customer gateway. Create a virtual private gateway. Attach the virtual private gateway to the desired VPC. Select VPN connections and create a new VPN connection. Select the virtual private gateway and the customer gateway. Once VPN is available, set up the VPN on the customer gateway or firewall. Global Accelerator. Create accelerators to improve availability and performance of applications used by a global audience. By default, Global Accelerator provides you with 2 public IP addresses that you associate with the accelerator. You can also bring your own. User connects to Edge location, which connects to the AWS Global Accelerators. They then decide which endpoint group to send the traffic to based on proximity, endpoint health and weighting. Onward to endpoint groups, and finally endpoints. Global Accelerator includes the following components: static IP addresses, Accelerator, DNS name, network zone, listener, endpoint group, endpoint. On creation, Global Accelerator assigns each accelerator a DNS name that points to the static IPs assigned. You can route to it by name or IP, or create your own DNS records to point to the accelerator. A Global Accelerator network zone is like an AS for Global Accelerator. It services the static IPs for your accelerator from a unique subnet. It is an isolated unit with its own physical infrastructure. If one of the two addresses becomes unavailable, clients can retry on the other. A listener processes inbound connections from clients to Global Accelerator based on port or port range and protocol. Supports both TCP and UDP. Each listener has one or more endpoint groups, and traffic is forwarded to endpoints in one of the groups. You associate endpoint groups with listeners by specifying the regions that you want to distribute traffic to. Traffic is distributed to optimal endpoints. Each endpoint group is associated with a region, and each group includes one or more endpoints in a region. You can adjust the of traffic by using the traffic dial setting. The traffic dial enables easy performance testing for new releases across regions. Endpoints can be network load balancers, application load balancers, EC2 instances, or elastic IP addresses. An application load balancer endpoint can be internet-facing or internal. Traffic is routed to endpoints based on configs such as endpoint weight to specify the proportion of traffic routed to each. Weight can be up to 255. You can configure an accelerator to always direct a source IP to a specific endpoint to maintain affinity. Accelerators must be disabled before deletion. VPC endpoints enable you to connect your VPC to supported AWS services and VPN endpoint services powered by private link, without an Internet gateway, NAT device, VPN connection or AWS direct connection. Instances in your VPC do not require public IPs to communicate with resources if the service, as traffic between your VPC and the service does not leave the Amazon network. Endpoints are virtual devices, horizontally scaled, redundant and highly available. Two types of VPC endpoint, interfaces and gateways. An interface endpoint is an elastic network interface with a private IP that serves as an entry point for AWS-supported services. Gateway endpoints are supported by S3 and DynamoDB.